Welcome to Finite Math, the rest of notes 3.2C. So number 24, we have the sine cubed of z times the cosine squared of z has to equal the sine cubed of z minus the sine to the fifth of z. So we can use one of our trig identities, again, one of the variations on the main one. Sine squared plus cosine squared equals 1. So that means that cosine squared can actually equal 1 minus the sine squared of z. And we'll just keep this sine cubed of z out here for a second. And that will equal the sine cubed of z minus the sine to the fifth of z. I was really excited for that 5. Make sure that you guys can see the notes a little bit better in there. And all we have to do is a little bit of distribution now. And we get the sine cubed of z times 1 is just the sine cubed of z minus sine to the third times sine to the second. Altogether, we have 3 plus 2 is sine to the fifth of z equals exactly what it was supposed to equal, equals itself. And that's number 24. So next up, number 28. We have to turn the secant squared of x minus 6 times the tangent of x plus 7, which kind of looks like a quadratic but isn't quite there yet, over the secant squared of x minus 5 into the tangent of x minus 4 over the tangent of x plus 2. So because I would like to change the more complicated side to be less complicated, I'm going to start on the left. And I notice that everything has to turn into a tangent. So we need to take all these secant squareds and we'll turn them into 1 plus the tangent squared according to the rule. So instead of the secant squared of x, we have 1 plus the tangent squared of x minus 6 times the tangent of x plus 7 over, instead of the secant squared of x, minus 5. But the secant squared of x equals, let's see, well, yeah, 1 plus the tangent squared of x. Minus 5. All that'll equal the tangent of x minus 4 over the tangent of x plus 2. Again, we don't really need these parentheses here because we're just adding and subtracting. We're subtracting from this set of parentheses, so we can just treat everything as a positive 1, still a negative 6 tangent, and positive 7, 1 minus 5. So let's simplify those a little bit. Looks like we're going to have the tangent squared of x, and then minus 6 times the tangent of x, and then 1 plus 7 is plus 8 over the tangent squared of x, and then 1 minus 5 is negative 4, and all that should equal the tangent of x minus 4 over the tangent of x plus 2. So now we need to factor both the top and the bottom, and hopefully something will factor to include a tangent of x minus 4 at the top and a tangent of x plus 2 at the bottom, and maybe everything else will cancel out. So double checking, if your a value is 1, your b value is negative 6, and your c value is 8, a times c, first times third, is 8. Middle number is negative 6. The two numbers that multiply to make 8 but add to make negative 6 are negative 4, one of the numbers we were looking for, times positive 2. And again, our a value was 1, so we'll just divide those by 1. So it looks like we're taking the tangent of x minus 4 times the tangent of x plus 2 over, again, a squared minus b squared. 4 is really 2 squared. So we can turn that into a, or the tangent of x, plus b, or plus 2, times the tangent of x minus b, or minus 2. Also, I noticed negative 4 plus 2 is negative 2. Negative 4 times positive 2 is negative 8. So I actually needed to make this negative 2. And this one should then be negative 2. Because now, in order to make this the tangent of x minus 4 over the tangent of x plus 2, these can cancel out. And we get that the tangent of x minus 4 over the tangent of x plus 2 equals itself, which is the definition of an identity. In number 30, we have some more fancy factoring, but again, factoring oftentimes means things get to cancel out. So we have the secant cubed of b minus the cosine cubed of b over the secant cubed of b minus, just the secant of b minus the cosine of b equals the secant squared of b plus 1 plus the cosine squared. So remember, anytime you have a number cubed minus another number cubed, whether it's a number or a function or something like that, the rule says we can turn that into the first number minus the second number times the first number squared plus the first number times the second number plus the second number squared. And that's exactly what we're going to do with the secant and cosine that are being cubed and subtracted in number 30. They're in the numerator. So we can turn that into the secant of b minus the cosine of b times a squared would be the secant squared of b plus a times b would be the secant times the cosine, which are reciprocal functions to each other, so that actually is going to be our 1 in the middle, plus b squared plus the second thing plus cosine squared of b. All of that over the secant of b minus the cosine of b is going to have to equal that. Again, secant b minus cosine b over secant b minus cosine b can cancel each other out, which leaves us the secant squared of b plus the secant times the cosine plus the cosine squared is going to have to equal the secant squared plus 1 plus the cosine squared. And again, we said that secant times cosine is 1, and everything else is already set. The secant squared of b plus 1 times plus the cosine squared of b now equals itself. Now you get to try your own.